Probability density function. Recall that there are two types of random variable. The first one is discrete random variable. The probability distribution of discrete random variable is called probability mass function or PMF. Now, when x is a continuous random variable, its probability distribution is called probability density function or PDF. Again, for discrete, it's PMF or probability mass function. For continuous random variable, it's PDF or probability density function. Unlike probability mass function, PDF cannot be placed in tabular form. So as you can see here, this one is an example of probability mass function in tabular form. This one is also an example of probability mass function in tabular form. So the probability density function will only be expressed in formula form and graph, not this one, not in table. The probability density function of a random variable x satisfies the following properties. Number one, we have the non-negative property. So when you say non-negative property, the value of the probability function is always non-negative. So meaning it's 0 and positive only. So that is function of x is greater than or equal to 0 for all possible values of x. Next is norming property. What does this mean? The total area of the region under the graph, because the probability density function is being represented by a graph, the total area of the region under that graph is equal to 1. That is norming property. Let's have an example. Let x be a continuous random variable whose probability density function is defined by this formula. So this is in formula form. Function of x is equal to 2 times 1 minus x if 0 is less than x is less than 1. And then 0 otherwise. So let's take a look at the graph of this. This one is the graph. This is the line 2 times 1 minus x. So function of x is equal to 2 times 1 minus x. And then from 0 to 1. So this is 0 and then this is 1. So it's a triangle. Now computing the area of this triangle, we have the height is 2. The base is 1. So 2 times 1 is 2 divided by 2 is 1. So the area of this is 1. And as you can see, the value of the probability function is non-negative. So all in positive. The area, this one belongs to the positive. Now let's talk about the support. The support of function of x, this is the definition of support, is the set of all values of x for which function of x is greater than 0. So in this case, the support of this function of x is the set of all real numbers between 0 to 1. Again, 0 to 1. So it's because of this. 0 is less than x is less than 1. Okay, next, compute the probability that x will assume a value between 0 and 0.5. 0 and 0.5. So from here, from this 0 to 0.5. In that case, we'll have this shaded part here. So this is a trapezoid. So we need to compute the area of this trapezoid. So computing for the area, we have the formula is base of 1 plus base of 2 times height over 2. Base of 1 is 2. This is base of 1 here. And then 1 base of 2. This is base of 2. And that is 1. 0.5, that's the height. This is the height. 0.5. And then over 2. So the area of this trapezoid is 0.75. Therefore, the probability that x will assume a value between 0 and 0.5 here is 0.75. Okay, so let's have this another problem, but the same given. Compute the probability that x is equal to 0.5. So exactly 0.5. Okay, so the area of a line is 0. So this is the line at 0.5. Therefore, the probability that x is equal to 0.5, exactly 0.5, is equal to 0. So it means that it's impossible to have 0.5 among all the infinitely many outcomes. Here, all the numbers here are infinitely many. So 1 over infinitely many is nearly equal to 0. So it's nearly impossible to have this 0.5 among all those outcomes. Okay, so let's have this example. Compute the probability that the birth weight of a particular mouse will fall between 1.0 and 1.2 grams. So this is 1.0 here, and this is 1.2. And this one here, the shaded part, has an area of 0.29. So it's already given. Which means that the probability that the birth weight of a particular mouse will fall between this 1.0 and 1.2 is 0.29. Or there is a 29% chance that the birth weight of a particular mouse will fall between 1.0 and 1.2 grams. Next, compute the probability that the birth weight of a particular mouse will fall below 0.75 gram. So here, in this example, it's already shaded because this is 0.75 and it's already shaded here, and the area of that is 0.159. So which means that the probability that the birth weight of a particular mouse will fall below 0.75 is 0.159. Or, in other words, there is a 15.9% chance that the birth weight of a particular mouse will fall below 0.75 gram. Okay, let's have the last example. The graph below shows the probability density function of the continuous random variable, the amount of rain that will fall tomorrow. Okay, the amount of rain that will fall tomorrow. Compute the probability that tomorrow will rain an amount of greater than 2 inches. Greater than 2 inches. So it's already shaded here. So we need to find the area of this. So it's a rectangle, therefore its length times width. Length is 2 and width is 0.4. So the area of the shaded part is 2 times 0.4, which is equal to 0.8. Therefore, the probability that tomorrow will rain an amount greater than 2 inches is 0.8. In other words, there is an 80% chance that tomorrow will rain an amount greater than 2 inches.